So this is the next question, 4b. Construct the signal flow graph for the electrical network shown. Also find C of S by R of S. Okay. They have given to find the transfer function and also to construct the signal flow graph and find the transfer function for this circuit here. So here this is the given circuit they have given. Okay. That is they have given the V1 of t, the resistance is R1, R2, R3, capacitance is C1, C2 along with the loop currents, or mentioned it as in the path of R1, that is I1 of t, in path of R2, that is I2 of t, in path of R3, that is I3 of t. So here also they have mentioned the nodes here, that is V2 of 3 and V3 of 3 t. So now in place of t domain, represent it in terms of S domain. So resistances would be remaining as it is, capacitors will be replaced by so here it is replaced by 1 by C1 of S, okay, and here it is 1 by C2 of C2S, okay. So yeah, then again draw the loops here, I1 of S, I2 of S, I3 of S. So I1 of S is equal to V1 of S minus V2 of S divided by R1, okay, since I is equal to V by R, right? So that's why here the two voltages are from V2 of S. If you observe, these are the two voltages in from in this loop, V1 of S and V2 of S, and one resistance we have between these two voltages, that is R1. So that's why I1 of S is this equation. Similarly for V2 of S, V2 of S, I2 of S, V3 of S and I3 of S, these are the equations here, so please note it down. After that, using these equations here, we should be drawing the signal flow graph like this, okay. So this is the signal flow graph for the particular circuit, okay. Yeah, so here what we should be doing is, so here if we consider this single path here, V1 and I1, so this is the input side and this is the output side, okay. But if the answer we have got is 1 by R1, because since we know that R is equal to V by I, right? But here we have I by V, okay, output by input, that is I by V, okay. So that's why I by V is reciprocal of R, so that's why I have written it as 1 by R1 here. Similarly here it is V by I, it is equal to 1 by C1 of S, since R is equal to V times I, and this is the impedance given here, that is the capacitive reactance, okay. So if we consider V by I, it is the same thing, it remains as it is, we should not be taking its reciprocal. Again I by V we have, so that's why this is replaced by 1 by R2. So here V by I, it remains as it is, 1 by C2S, I by V 1 by R3, and these are the loops here which touches like this, that is minus 1 by R1, minus 1 by C1S, minus 1 by R2, minus 1 by C2S, okay. So like this we should be constructing the signal flow graph. So now the same thing, forward paths, loop gains, non-touching loops, all of them. So first thing, forward path. So here if you observe here, we have only one single forward path from input side to output side, that is P1. Multiply all the gains here in this forward path, 1 by R1 into 1 by C1S into 1 by R2 into 1 by C2S into 1 by R3, all multiply all of them. This is the P1 we get in final, that is S and S we have, so it would be S square, C1, C2, R1, R2, R3. So this is the forward path P1. And similarly the loop gains, it is evident that we have 4 loops here, 1, 2, 3, 4, okay. Write all of them, all of their loops here, multiply the gains here for all of them, okay. That is L1 is minus 1 divided by R1 C1S, L2 is minus 1 divided by R2 C1S, L3 is minus 1 divided by R2 C2S, L4 is minus 1 divided by R3 C2S. So then taking two non-touching loops, okay, taken 2 at a time first, okay. That is, if we see that we have 4 loops here, if we take 2 at a time, this one loop and this one loop, so these 2 loops are non-touching, okay. So that's why I've written L1, L3, okay. Multiply L1 and L3 whatever we got and write it. Then again if we take 2 at a time, these 2 loops, that is L1, L4, okay, that also these 2 loops are again non-touching, right? L1 and L4 are non-touching again, so that's why L1, L4 write its value by substituting here L1 and L4. So L2, L4, again if we take L2 and L4, we can see that these 2 loops are again non-touching, so that's why L2, L4, substitute the value from this and write it, okay. So these are the 2 non-touching loops taken 2 at a time. We cannot take 3 at a time, because since we have only 4 loops touching together, so we cannot take 3 at a time once, okay. So that's why. So now delta 1, since we have path P1, that is delta K1 minus loop gains which do not touch the forward path here. So all the loop gains are touching this forward path only, so that's why we don't have any loop gain which do not touch the forward path, so that's why delta 1 is equal to 1. So now apply the Mason's gain formula, C of S by R of S, that is P1 delta 1 divided by 1 minus summation of loop gains, 1 minus summation of loop gains taken 1 at a time plus summation of loop gains taken 2 at a time. Okay, then substitute the values of L1, L2, L3, L4, L1, L3, L1, L4, L2, L4 here separately and write the final transfer function. Okay, so this is the final transfer function. I've kept it as it is. If you want, you can cancel this term here by taking the LCM here. It is again the lengthy procedure. Okay, if you want, you can do further, you can solve it and cancel this and write the simplified expression, or else you can keep it as it is. You will get the full marks. Okay, if you keep it as it is as well. Yeah, so this was the simple problem for signal flow graph. Okay, so please note it down. So this problem is very important. Okay, derivation of peak time. Okay, so what is this peak time, or we can call it as TP. So now let's start deriving this TP, peak time. So first thing, write the output response equation which we have derived, that is C of t is equal to 1 minus e to the power minus zeta omega nt divided by square root of 1 minus zeta square. Okay, sine omega dt, sine of omega dt plus theta. Okay, so now what we need to be knowing is, that at t is equal to Tp, the C of t or the output response would be reaching its maximum state. Okay, so therefore we can say that C of t would be maximum. So now according to this maximum theorem, what we can say that the derivative of dt with the derivative of the output response with respect to time, where the time is equal to the peak time here, that is equal to 0. Okay, according to maximum theorem. So now without any further ado, let's according to this maximum theorem, let's so go on solving. That is, let's take the derivative of this C of t. So after the derivation, what we are getting is the expression is minus e to the power minus, so derivation of 1 is 0, so that term would be getting neglected. So the remaining terms are minus e to the power minus zeta omega nt into minus zeta omega n, that is the coefficient of t here, minus zeta omega n, sine of omega dt plus theta divided by square root of 1 minus zeta square. Okay, minus, so here we are using the UV rule. Okay, e to the power minus zeta omega nt divided by square root of 1 minus zeta square into omega d cos of omega dt plus theta. Okay, so why I have read, so again in this case I have taken the UV rule for this term. Okay, that is first term into the differentiation of second term, or differentiation of first term into second term minus first term into differentiation of second term. That is, so here the differentiation of first term I have taken into the second term minus first term into the differentiation of second term, that is sine omega dt plus theta. Okay, sine omega dt plus theta differentiation of sine is cos omega dt plus theta, and the coefficient of t, that is omega d, have written it first. Okay, so now in this equation what we need to do is substitute the value of omega d is equal to omega n into square root of 1 minus zeta square. Okay, so now what we would be getting, so minus into minus is plus, so let's write that first, zeta omega n into e to the power minus zeta omega n t, okay, divided by square root of 1 minus zeta square into sine omega dt plus theta minus e to the power minus zeta omega nt divided by square root of 1 minus zeta square. So now in place of omega d, we need to be substituting it as omega n into square root of 1 minus zeta square. Okay, into cos of omega dt plus theta. Okay, that is equal to 0. Okay, since the derivative of the C of t is equal to 0, so don't forget to write this equal to 0 sign. So therefore, so now what we can see is, we can take this term outside constant. Okay, in these two terms we can see that omega n into e to the power minus zeta omega nt, that is e to the power minus zeta omega nt into omega n, we can take it common outside, that is omega n into e to the power minus zeta omega nt Also we can take this square root of 1 minus zeta square common, and the remaining terms are zeta sine omega dt plus theta minus square root of 1 minus zeta square cos of omega dt plus theta equal to 0. So again we can see that these two terms are getting multiplied, so and the answer is we are getting it as 0. So we can say that from these two terms any one of the term is equal to 0. But here in this case we have omega n in this term, so we know that we can say that since omega n cannot be equal to 0, since the omega n is called as the natural frequency of oscillations. Okay, if there is no frequency of oscillations, there is no response created, so that's why we can say that this term is not equal to 0. So definitely this term would be equal to 0, that is zeta sine omega dt plus theta minus square root of 1 minus zeta square cos of omega dt plus theta is equal to 0. Okay, so now we can simplify this, that is zeta sine omega dt plus theta is equal to square root of 1 minus zeta square cos omega dt plus theta. Okay, I have just taken this term to the other side. So now what we can do is we can write sine of omega dt plus theta divided by this term I have taken, I am bringing it to the other side, that is cos of omega dt plus theta is equal to, in this side we have square root of 1 minus zeta square, and this zeta I am bringing it to the other side, so that is equal to divided by zeta. Okay, so now what we would be getting, sine by cos is tan, so tan of omega dt plus theta is equal to square root of 1 minus zeta square divided by zeta. Okay, so this is the relation which we are getting. But we have one more relation for this term if you observe carefully, that is we know that tan theta is equal to square root of 1 minus zeta square divided by zeta, right? So in the previous derivation for output response we have seen one relation, right? Tan theta is equal to square root of 1 minus zeta square divided by zeta. So what we need to do is we need to be equating these two terms, that is, so after equating those two terms what we are getting, tan theta is equal to tan of omega dt plus theta, right? So this is one more relation which we are obtaining. Okay, from this relation only we have one more trigonometric formula, right? We know that from a trigonometric identity we would be obtaining one relation, that is tan of n pi plus theta equals to tan theta. Okay, this is one identity which you need to be knowing. So here if we compare this equation and this equation, what we can see, in place of n pi we have omega dt. Okay, so that's why we can equate those two terms. Therefore we can say that omega dt is equal to n pi. Okay, where the value of n lies from goes from 1 to 3 up to infinity. Okay, and also we have taken initially the value of t is equal to tp, so therefore we can say that omega d tp is equal to n pi. Okay, but the value of n we should be taking it as 1 because we are doing the derivation of first overshoot. Okay, the derivation of tp at first overshoot, so that's why we need to be taking the value of n is equal to 1. So now what we are getting, omega d tp is equal to, the value of n is 1, so pi, so therefore the value of tp we are getting it as pi by omega d. Okay, so in this way we are deriving the expression for tp, that is peak time. So the final answer which we are getting is tp is equal to pi by omega d seconds. Okay, so this was the derivation of peak time So now let's see next see the derivation of peak overshoot MP. Okay. So now let's see the derivation of peak overshoot MP. Okay. So now from this figure we can see that here this is the set amplitude, we are taken it as 1. Okay, and here this is the range of MP. Okay, so from this figure we can say that MP is equal to C of TP. Okay, C of TP minus 1, that is C of TP means, so since this is the value of TP, okay, so this whole thing would be C of TP minus 1. So the whole C of TP minus 1, we are getting the value of MP. Okay, yeah, so this is complete C of TP. Okay, and this is 1. Okay, so if we take the subtraction of this and this, if we do the subtraction, only this region would be remaining. Okay, that is called as MP. Okay, peak overshoot. So now so we have got this condition. So now according to this condition, let's substitute the value, that is MP is equal to C of TP or C of T, where the value of T is equal to TP. So substitute the value of C of T, that is 1 minus e to the power minus zeta omega n. In place of t we need to be writing it as Tp now. Okay, since t equal to Tp, square root of 1 minus zeta square sine of omega dt plus theta minus 1. Okay, so we can say that 1 minus 1 is 0, so we can cancel it out. So MP is equal to minus e to the power minus zeta omega n Tp divided by square root of 1 minus zeta square sine omega d. In place of t we need to be substituting it as Tp, omega d Tp plus theta. Okay, so here we know that we have this, just now we have derived the relation for Tp, right? So Tp is equal to pi by omega d, right? So just now we have derived it. So now in this equation again substitute the value of Tp as omega pi by omega d. So minus e to the power minus zeta omega n Tp, here you keep it as it is, divided by square root of 1 minus zeta square sine of omega d into pi by omega d in place of Tp plus theta. So your omega d would be getting cancelled. So final expression of MP, what we are getting, minus e to the power minus zeta omega n Tp divided by square root of 1 minus zeta square into sine of pi plus theta. Okay, so this is one expression here, but we have one more trigonometric identity if you observe here, that is sine of pi plus theta. Sine of pi plus theta is generally equal to sine theta according to a trigonometric identity. So now in place of sine of pi plus theta, substitute it as sine theta. So now this is the expression here we are getting. Okay, so now please note this expression and take this expression as equation 1. Okay, so now let's further derive it. So now we know that we have one relation, that is tan theta is equal to square root of 1 minus zeta square divided by zeta, right? But in generally, if we draw a right angle triangle, okay, where this is the angle theta, okay, so in generally what is tan theta? It is opposite by adjacent, right? So now in place of opposite side, what we are having, square root of 1 minus zeta square. So write it here, square root of 1 minus zeta square, and adjacent side is zeta. Okay, so the remaining side is the hypotenuse. So now take that hypotenuse as 1 since it's not given. Okay, so now from this tan theta and from the equation 1 which we have taken, that is here we have sine theta, right? We have obtained sine theta, right? So now in place of sine theta we can write here it as, we can write it here as, since sine theta is equal to opposite by hypotenuse, right? So now what we can write, opposite side we have, that is square root of 1 minus zeta square, and hypotenuse, since it's not mentioned, we can take it as 1. So from this relation we can obtain the value of sine theta, that is square root of 1 minus zeta square. Okay, so now substitute this value of sine theta in equation 1. So now equation 1 would be MP is equal to e to the power minus zeta omega n Tp divided by square root of 1 minus zeta square. Now in place of sine theta, substitute square root of 1 minus zeta square, so that we can cancel these two out. Okay, so the remaining term is mp is equal to e to the power minus zeta omega n Tp. Okay, and also we have the relation of zeta omega n Tp is equal to e to the power minus zeta omega n into pi by omega d, right? And also e to the power minus zeta omega n into pi by omega d is what? Omega n into square root of 1 minus zeta square, right? So here we can cancel omega n and omega n. So our final expression for mp, we are getting it as e to the power minus pi into zeta divided by square root of 1 minus zeta square. So this is our expression which we are getting it for peak overshoot. And also if you want to calculate the percentage of peak overshoot, what we need to be doing, e to the power minus pi zeta divided by square root of 1 minus zeta square into 100. Okay, in this way you can calculate the percentage of peak overshoot in case if they ask in the problem. Okay, so this was the derivation of peak overshoot or MP. Okay, so now let's see the derivations of rise time and settling time. Okay, so here the next derivation is derivation of TR. Okay, that is rise time. Okay, so now here in this plot we can see that this is the rise time here. Okay, this region is called as the rise time. So here this is the rise time TR, where it is going above the given level, that is given unit step, that is it is going above 1. So where it, in which point it's going above 1, that point from the origin we can say that it's the point of TR. Okay, yeah. So for derivation of TR, again what we need to be taking is the output response C of t, we need to be taking at t is equal to TR. Okay, that is equal to 1. Since the TR is till its range is only from here to here, so we can say that from 0 to 1. So we can directly write the value of C of t is equal to 1, where the value of t is equal to TR. So again now substitute the value of C of t, that is 1 minus e to the power zeta omega n t, in place of t substitute it as TR divided by square root of 1 minus zeta square into sine omega d TR plus theta is equal to 1. Okay, so now again this 1 and 1 we can cancel, or we can take this 1 to other side, so that would be 1 minus 1. So here we would be getting 0, that is minus e to the power zeta omega n TR divided by square root of 1 minus zeta square sine omega d TR plus theta is equal to 0. Okay, so this equation would be getting satisfied when sine omega d TR is equal to 0, since these two terms are getting multiplied again. Okay, so that's why any one of the terms should be equal to 0. But here in this case e to the power zeta omega n we have here, but this omega n is not equal to 0, right, since it is the natural frequency of oscillation. So that's why this term should be equal to 0. So that's why sine omega d TR equal to 0. Okay, sine omega d TR plus theta is equal to 0. But in generally we can say that we have one more trigonometric identity, that is sine n pi. Okay, sine of n pi is equal to 0. Okay, where the value of n goes from 1 to up to infinity. Okay, always the value of sine n pi is equal to 0. But in place of n pi we have omega d TR plus theta. So that is omega d TR plus theta is equal to n pi. But here the value of n is equal to 1, since we are considering for the first overshoot, that is the first response we are considering. So that's why we can take the value of n as 1. So therefore omega d TR plus theta is equal to pi. So therefore the value of TR we are getting it as pi. So this plus theta, if you take it to other side, it would be minus theta divided by omega d. So this is our expression for rise time, that is pi minus theta divided by omega d. So this was all about the derivation.